Hi everyone, Alex is here. Let's check TensorFlow Playground. So that's what we have. If you haven't been trying that before, try it out right now. Playground TensorFlow. What is that? It's for you to understand how does the core of AI is working, how does all that models are working, and what we can do with that. So basically, that's for you to train, to understand, to check the difference here at once. You shouldn't wait for long to understand all of that activations, hidden layers. You can understand that and check it just right now. And let's experiment. Literally, I'm not very in all of the tasks, but I really like to experiment. And I wanted to check with you today what can we have. And let's go with quite basic one that is instantly is given for us. It's we have 4 data. It's with these dots that we just should cover all with our orange and blue lines. That's all. So we can see here this one. We can see here such squares on one side and the other, and the killer one is this one, spiral one. Why so? We'll check. So let's go from this one and the example that we have. Just how to work with it. Just click run and you'll see how does it work. And you can see it's instantly working. That's how it's amazing example of AI that is working. And then you just will be waiting until I don't know even what. And let's close it up. So that's how many epochs we have been to check that out. So let's check what do we have. We have 2 inputs, so 1, 2, and we have 4 neurons, first ones, and you can discover how does it look for each of that neuron. And what do we have then? How we can look at that? So you can see we have 2 of them. One is blue, another one is orange, and after that all there go is you can see also weights here. You can see all of that is weights, and that was I was talking to you in the previous videos that each of that thing, this one, is your activation, and each activation here has a weight that you can change. And let's check it out how it will be if we, for example, will have 3 layers with 3 neurons in the end. And if you think that more is always better, not. Let's check what we'll have right now. It's maybe this one has been working good. Okay, maybe that was a good example of that. But in general, that's this way is quite good currently, but there is no need of this 3rd layer. It's makes it complicated, as I remember, and it's better to concentrate on I can just make it this way. And it's better to concentrate on these 2 because it will be a lighter version of your model and it will be working faster. So we can use another, for example, method just for you to understand how it all changes. Let's work with liner. We can see problems from the very beginning. And you think why? Because an idea of liner is quite different. And for that you can use graphics. So in graphics you can see how liner is on the line, ReLU is in this way, and etc, etc. So let's use ReLU for example. It worked but not so good at that one. And can you see? Hope that you can see these things. It's sharp. It's one of the most interesting things that it's sharp. And you will be using, for example, sigton, you will be able to see that it's round. It's quite big difference for this model. Let's go to sigmoid, for example. You can see that sigmoid is trying to be something better, but it was quite hard for it also. So what we can see from all of that? that activation is one of the most important things for you to know. It doesn't mean there is one way of doing that. For example, we can go linear, for example, here. It will be the best where you can use that. Even with, I think, with such, instantly, just instantly. Why? Because it's a linear question here, and we should have a linear solution. Just line to divide these two parts. We can, I think, do that with different one. I don't think, like, let's check with C. No, I think with Simulate also, but maybe it won't be as good as Liner. Yeah, it was quite good, but not so as Liner. Let's go with Stun. It's also quite good, and it has, you can see it's more round. It's not just about the graphics, it's about to logically understand how does it work. And you can also see it here, for example, how it how does it compare. So it's first it compares in this way, then in that way, then in that way, and then it just finds the perfect spot, like just combines all of them and find the best between them two, like on this angle and on the up one. So for the bottom and for the top one, and then we have this image. Like, what do we have? But the most interesting comes here. Because let's discover what we'll have if we'll be using liner. We cannot use it here because it will try to make a one whole line where it can do that. Where there is no way of doing that. It's spiral. Let's go with, for example, a ton. It's making much better job, but you can see how hard is that for it to understand. It's because it's not enough. You can see byte spot, it's not enough data for it. It's going too much to both of them, and it cannot understand. It's too many data to proceed, and too alas neurons in the hiding layers. Let's add 4 of them, like 2 more to the edges, and let's discover what we'll have. We have much better result. Not like incredibly better, but we can see that it understood this blind spot. So what we can understand, maybe we should have more. So we can just divide all this 4 to go all of the way around. So we can have, for example, here 8, the maximum one. Here we can go for 6, and the third layer for 2, for example. Let's go and discover what we'll have from that. So that's why it's ideal spot to experiment, to discover how should it work. And you can see that it finds the spot to go through these dots, and we have something, yeah, that's much better. And okay, that's what we have. And just let's change one thing, only one, activation. Firstly, you see how different it's trying to. That one was going longer, but here we have a lot of losses at one point. At one point we had a lot of losses, but the image of itself is a little bit better, but we also see these sharp corners. So that's the question. You can discover training loss here and training loss there. Test losses that we have currently not so big, so it's quite good, but discover we can have learning rate, so it can learn faster or it can learn slower. For example, we can make it 0, 1. It can be extremely faster, extremely much more data. Let's go reverse here. And let's discover, maybe it will help us. You see, not. It's making too many losses here, and when it's jumping, I don't remember how it's calling, but that's not the good sign of that. It means that it's overloading and it's trying to more to remember than to understand. So we should definitely put it less. And learning rate on this place is quite ideal. We can, for example, go to the next way. We can go, for example, this way, plus, for example, have 8 neurons, and here to have 6 of them. And let's discover what we'll have with sigmoid. So once more time, you can check it out, discover, experiment, and for example here it's nothing to show us, but maybe tan will. So what we can see that x1, x2 is too complicated and too not working for all of that. But let's discover what we'll have in this way. I like done for this solution when it's more smooth, for example, than our relief one. So you see the jump, not good thing. But I'm not extremely good model engineer, I'll say in this way. So try to experiment with it. So this is the main idea of this playground TensorFlow, because not a lot of people I have met know about this tool and how to use that, and an idea for discovering that, because it's even for me quite hard still to understand all of the things with hidden layers, neurons. I'm trying hard, and I will. But even before that, it's still quite hard. But with this tool, you can significantly faster understand that. Also, you can have, for example, regulation. Discover new tools for you, because here we have mostly everything that we should have to discover that. And say that we don't have AI that will say why this solution is good or bad, but maybe they will add it a little bit later. But we have our ChatGPT, Gemini. You can use them to discover why it was using in this way, and it will make faster your learning. So check it out, discover how to work with that, and don't lose time. That's the thing. Thanks everyone for watching. See you. Bye.